Hi, welcome to the Samplecraze Compression Primer tutorial. This is going to be a beginner's tutorial, and it's going to be very simple. I'm going to concentrate on how to adjust or change the gain of an audio file without trying to change too much of its tonal characteristics. And I'm going to show you how a compressor works and what the functions on each compressor are. In later tutorials, I'll be getting into some very detailed audio examples showing you how to use different types of compressors, whether they're FET based, optec compressors and so on. I'm going to show you how to use corrective or transparent compression purely to adjust gain, and then I'll be using colored compression to impart a distinct character onto the audio. I will also be showing you how to use compression to completely reshape a sound, to maul it, to extend it, to do whatever you want, to give a feeling of ambience, to make it up close and personal, and so on. But for this particular tutorial, I'm going to keep it extremely simple. Now, what we have here is an audio file that I've loaded of a very simple piano line. As you can tell from the shape and looking at the values on the left here, this is very low in volume. You can also tell once it starts to play, have a look at the metering here, and this will show you what its peak values are. Okay, you can see that it peaked at between 15 to 16 dBs below zero. So we know it's quiet, we heard it's quiet, and we can see it's quiet. What I want to do now is use one of the simplest compressors that I have. And it's a great educational one because it hasn't got any fancy functionality on it like other compressors do. It doesn't have any side chaining. It doesn't have any content analysis type of feature sets that you get, like look ahead functions, etc. It's just a very simple compressor. It's the Blue compressor. Okay, this is pretty much as simple as it gets. So I'll run through what each one of these does, and then we'll bring it into use on that audio file. This is the gain slider. This determines how much of an input gain we want on the audio signal coming into the compressor. The threshold. This is the input level above which compression occurs. Above this level, the output increases at a lesser rate than the corresponding input stage. So let me put that in really simple terms. Threshold is all about gain. It's not about frequency. So this isn't looking at an A3 or a C4. It doesn't care about frequencies, not yet anyway. We haven't used the sidechain, the key input function. So this is completely gain dependent. And if we set the threshold, let's say high, we're only going to compress the loudest peaks in that audio signal, that piano audio signal. If we set this, say, all the way down to here, we're in effect going to compress the entire audio signal. And we don't really want to do that for now. All we want to do right now is take the peak values and just affect compression on the peak values, bring them down a little bit, and bring the overall gain values up. We'll do that in the example. Ratio. This is the ratio of the change in input level to the change in output level. So to put that in really simple terms, let's say you have 2 dBs of signal coming in, and I give this a value of 2 to 1. That means that 1 dB is output. If I have 4 dBs coming in at 2 to 1, I have 2 dBs going out. If I have 8 dBs coming in at 2 to 1, I have 4 dBs going out. If I had 3 dBs coming in and I set that to 3 to 1, or thereabouts, I'd have 1 dB going out. So a simple way to do it is just divide it into the input gain value. Softness I'll get to in a minute when we have a look at the way the graphical representation of what these functions do. So what we'll do right now is get into the attack. This is how fast the compressor reduces the gain when a signal is input. How long it takes to kick in, that's it. And release is the opposite. How long it takes for this to jump back to neutral. So small release values mean the compressor will return back to neutral very fast. These are all quite important actually, because these shape how the compressor will work depending on the material we're going to compress. This metering is actually what we call GR. It's not, they don't call it that on the blue compressor. As I said, it's a box standard compressor. But GR means gain reduction. It's just simply an indication of how much the level has been attenuated by the compressor settings. This volume slider is actually very important. It's the gain compensation. Basically, when you start using really heavy compression ratios on a lot of the material, if you think of it this way, if you think, say, 3 dB is coming and 1 dB goes out, we might want to push this up to bring that 1 dB back up to 3 dB. So you're thinking to yourself, well, why use the ratio tool? Well, remember, we're using the ratio tool above the threshold. I basically just say, look at your metering and listen to it. So what I'm going to do is load up what I've created here as just a standard compressor. And if you listen to it in bypass mode, it's still pretty quiet. If I kick in the bypass mode, you even with very subtle settings like this, you will hear a difference. Now you can see my metering is not very high, so I'm going to gain compensate this. And I'm going to do this by visually and by ear. You could even have a look at the edge out here, the metering on the edge here. That'll give you an idea of how much we've raised the gain. Now when I render this and press OK, have a look at the file, and I'll of course undo it and redo it so you can see the differences in the peak values. Because I'm using very low threshold values and I'm not compressing all the signal, I'm really just trying to tame the peaks here by a value of 3:1 to bring it more in line with the lower levels. Basically, in the old days, a compressor, and a definition of it, was to make the loud bits quieter and the quiet bits louder. It's all about perception. The idea being that we wanted to have a more uniform dynamic range to the audio signal, and so everything sounded a bit louder but without compromising the dynamic or the sonic integrity, which we will do in later examples. Now's a good time to get into the softness. If you look at this curve, I'm not going to get into what represents what right now. All I want to talk to you about is the softness. This is your signal coming in, and at the threshold, this is the compression that's taking place. If I bring this all the way down, you will see what happens here. This is what we call a hard knee, because it's shaped like a knee. So basically, you get to the threshold, the compressor kicks in, and it's quite dramatic. Trust me, if I raise the ratio value, that would really start flattening out. With some material, we don't want that. So what we want to do is give it a nice, smooth curve. So the compressor gradually comes in, and it gives a much more natural effect. And this is what Blue calls its knee setting. It calls it softness to hardness. Other compressors will actually call it hard knee, soft knee, and so on. So you can see how that's changing. It's becoming far more smoother and more gradual. So let's render this, and you can see what a dramatic change that made to the audio waveform. Here, I'll undo it, and I'll redo it. Now have a listen and look at your metering here. I mean, it's already, we know the peak values because I've already played it, but just have another listen to it and another look at the metering, and try and determine if the audio has been compromised. By that I mean if you get some kind of anomalies, or if it sounds too grungy or dirty, loud in certain parts, quiet in others. It shouldn't do, because we picked some very subtle values. And there you go. In later examples, we'll get into mauling sounds and using compressors for completely reshaping dynamics. the do's and don'ts, and so on. Hope this has been helpful, and thanks for your time.